Hello and welcome to Biblical Genetics. I'm Dr. Rob. If you've seen any of my other episodes, you know that I like to go to strange and unusual places and then think of some sort of catchy little tie-in to the subject of biblical genetics. Well, I'm in my backyard. I'm sitting right next to my beehive. I'm literally my nose is a foot away from certain death, or at least some very difficult situations, very close to me. And I want to use that as a tie-in to the use of fetal cells in medicine. Things that you and I are going to directly interact with in the very near future. New scientific discoveries, new medicines, new treatments, vaccines, all sorts of things like that are right in front of us and potentially very dangerous morally. If you saw my last episode, I talked about developments in using adult stem cells. We talked about tracing the path of embryological development by sequencing cells in an adult body. We talked about how some scientists had taken adult skin cells and turned them into embryo-like things. In other words, human cloning is right around the corner and we're on the verge of being able to clone humans, and how dangerous and difficult this conversation is. We are now going to discuss the 5 classic cell lines that have been used in medicine going all the way back to 1951. 1 adult lineage and 4 lines that were taken from aborted children that have been used in a lot of medical procedures and a lot of developments, a lot of things that you and I have actually participated in. In the future, we're going to talk about politics, we're going to discuss ethics, and we're going to discuss privacy. Little hints here and there in this talk, but what I want to do is cover the 5 classic cell lines. Cell line number 1 is called HeLa, H-E-L-A. That is a code name for a woman. Her name was Henrietta Lacks. She died of cervical cancer in 1951. Now, she never gave permission for doctors to sample her tumor, and she never understood that people were going to make millions of dollars off of her. 2 Nobel Prizes have been awarded based on work in the cell. Over 60,000 scientific papers have been published on HeLa cells. These cells are all over the world. Multiple different sublineages have been made. In fact, these cells contaminate a lot of cell cultures and a lot of laboratories around the world because cancer cells reproduce essentially forever. Now they can self-destruct, fine, but they have no regulation of cell growth. The adult body is tightly regulated. When cancer hits us, the reason we die is because the cells keep on growing until, well, they basically take over. But HeLa is a cancerous tissue, one of the most cancerous, one of the most fast reproducing, one of the strangest things anyone's ever seen. And they're weird scientifically because they have a lot of chromosomal abnormalities. They're not really quite human anymore, yet they started from human, but they're weird. HeLa has been very important. If it wasn't for HeLa cells, we would not have had polio vaccines. In fact, HeLa was used to discover the relationship between HPV, that's a human papillomavirus, and cancer, because Henrietta Lacks died of cervical cancer. She carried HPV. In fact, the cell lineages that have been derived from them, they carry HPV as well. There was a big brouhaha in 2013 when her genome was sequenced and published, and the family got angry because scientists, you've got no right to publish our close relatives' DNA. And so the scientific community said, yeah, okay, we understand. This goes back in the day when we didn't even ask permission from people. We just took stuff. Well, things have changed. So what they've done is they've put her genome in a box, and you need permission to be able to use it. And there's a list online of all the scientists that have permission to study her genome. It's kind of a compromise situation. Ugly stuff, poor African-American woman, no permissions granted, really nasty politically. That's the first cell line. Cell line number 2 is called WI38. WI is the Wistar Institute at the University of Philadelphia. A child was aborted in 1962 in Sweden. Somehow the samples were sent to the Wistar Institute, and a man named, sorry, it's hard to talk when we talk about abortion. A man named Leonard Hayflick, who is very famous because he gave us the concept of the Hayflick limit. That is, human cells only divide a certain number of times before they stop dividing. One of the reasons why all these cell cultures are targeting fetal cells, and a lot of the newer technologies now are using fetal cells, is because they have a longer lifespan before they stop reproducing. The Hayflick limit. Well, Hayflick understood this limit, so he took samples from this child and he grew tissue cultures, just single cell culture in his giant vat, and then he subdivided it into things we call aliquots, little samples, aliquots, and then he froze them. So future scientists could say, hey, can I have a sample of WI-38? Yeah, sure. And they send a sample, they pour it into a big vat of nutrients, and they can grow up another set of cells from that original cell culture. A parallel lineage made about the same time, MRC5, was made in the United Kingdom in 1966. It was also aliquoted and frozen. These two cell cultures were incredibly important for medicine in the 60s and 70s, maybe even today also, but definitely back then. A lot of different vaccinations that were developed around that time were grown on these cells. Grown as in they grew the virus that caused the disease on the cells, but instead of growing the cells at body temperature, they grew them at a low temperature. So after several generations of that, they'd raise up a bunch of viruses in the cells, take a sample, put it in a new fresh batch of cells, raise it up, put that new fresh batch of cells, raise that up, and eventually those viruses could no longer replicate at body temperature. And those are the basis of a considerable number of vaccines that were given in the 1970s specifically. I know I got them, most Americans have gotten them. That was the way a lot of vaccines were developed. So we had problems with HeLa. The problems with WI-38 and MRC5 is, well, back in the 1970s, there was no Google. If you wanted to learn what was in the immunization the doctor was giving you, if you weren't an insider, it would be almost impossible to know. I mean, yeah, you could go to a university library and you could start learning and reading some of the scientific literature, and you could start trying to put a paper trail together, but things that were done in private universities or government reports and things like that were a lot harder to find. And I wonder how mothers would have reacted in the 1970s, 1980s, if they knew that their vaccines were being grown on cells directly derived from aborted babies. Except a couple of things. People remembered polio and how bad it was. People remembered the German measles, rubella. In fact, in the 60s, rubella was the leading cause of birth defects. Blindness, deafness, congenital defects most of those cases actually were attributable to the mother being infected with rubella when she was pregnant. And this was terrible. And so, given the choice, mothers would say, well, I know an evil has been committed, abortion occurred, and yet I can't fix that. I can't go back in time, and I have a cure here or a preventative that might prevent my child from being deformed. That's not an easy thing to be faced with, but I think most people would have taken the route of, I can't fix it, let's protect my child now. And then in the future, maybe let's make some laws or something so this never happens again. Hold that, we're gonna be talking about that again in the future, I am certain. The next important cell line is HEK-293. If you've been following the COVID-19 vaccination debate, I'm certain that you've heard of this. HEK, human embryonic kidney. It was made in the laboratory of Alexander van der Ebb at the University of Leiden in the Netherlands from a child that was aborted in 1971. This is before abortion was legal in the Netherlands, except they had an exception, threat to the life of the mother. And yet that's been a rather porous barrier for a long time because, I mean, what if the mother has gestational diabetes? What if she has hypertension? There's all sorts of things. I mean, pregnancy is dangerous if you're a woman. It's physically demanding. And who knows what happened, but so I'm getting emotional again. I'm trying not to be emotional. This is very difficult. From prior work on monkeys, they understood that you could take kidney cells and transform them. 2 points here. One is transformation. That is, if you expose the cells to an adenovirus, they can become cancerous, and cancer will reproduce forever. You're not subject to the Hayflick limit. 2, kidneys. Yeah, we're not talking about an early stage pregnancy. We're not talking about a ball of cells. We're talking about a little human-shaped baby that actually has kidneys that can be removed and dissected and a specific cell type taken out of that, cultured, exposed to an adenovirus. That's HEK-293. We don't know the number of experiments that were performed before this was developed, but Frank Graham, the man who did this work in this laboratory, who later on moved to Canada, I think it was McMaster University, he finished his career at, he performed the work that led to development of this cell line, and he had a habit of numbering his experiments. So 293 tells us a lot of experiments. However, Van der Ebb remembered the fetus. And if he remembered the fetus, that means that he's not working on thousands of dead babies, but he is working closely with the hospital, because at that time, an abortion had to be performed in the hospital. There were no abortion clinics in the Netherlands at this time. So he's working with the hospital, he gets a fetus, a baby, he dissects it. A year later, I think, this other scientist took it and got the cells and made HEK-293. Let me quote you something that Van der Ebb said at a conference in the United States decades later. He said, "The fetus, as far as I could remember, was completely normal. Nothing was wrong. The reasons for the abortion were unknown to me. I probably knew it at the time, but I got lost, all this information." Okay, there's a little giveaway here. We might have lost the paperwork. If that's true, HEK-293 might not be protected by any sort of a legal system. There's something else about HEK-293, and I assume the next one I'm going to talk about, which is called Per.C6. But this cell line has a lot of chromosomal duplications. One of the classic things in cancer is because there's not a lot of error checking as the cells grow like crazy, you get accidental chromosomal duplications. And HEK-293 doesn't have 46 chromosomes like a normal human nucleus. It has, on average, 64. On average. Some have less, some have more, and it's not stable. Different cell lineages that have been derived from this have different chromosome counts. So because there's permission problems, therefore probably privacy problems, and because it's not really a good model of normal human cells, scientists are looking for a replacement. And they're going to replace this one eventually. The next one I want to discuss is called Per.C6. It was also manufactured in the laboratory of Van der Ebb at the University of Leiden. This was made in 1995 from an abortion that occurred in 1985 by two other scientists. Now, this was the year after abortion had been made legal, and Van der Ebb said there was nothing special with the family history, or the pregnancy was completely normal up to 18 weeks. The woman wanted to get rid of the fetus. There was permission, etc. So apparently there is some paperwork documentation for this, but Per.C6 is a proprietary product of Johnson & Johnson. They bought the company that Van der Ebb gave the cells to initially. This is why Johnson & Johnson grows their coronavirus vaccine on Per.C6, because they own it. All right, there you have the top 5 cell lines used classically in medicine. These have been used to develop a lot of different vaccines, a lot of tests for bacterial or viral contamination in cell samples or tissue samples from sick people. They've been used for a lot, an incredible number of experiments. Each one of them has some moral issues to it. One because there was no permission granted, and one because they had to murder children to develop these lineages. We're going to get into the moral aspects, I believe, in my next episode. I've got to gear up for that one. But I just want to give you a little teaser. This is not something new to the world of Christianity. Theologians have been wrestling with this for literally centuries. We live in a sin-cursed world. Nothing that humans do is untainted. Everything we do is influenced by history of sin. We're talking about murder, theft, greed, corruption, in sciences and medicine and politics. There's not a single person in the world who doesn't have blood on their historical hands. Essentially the reason why we are where we are is because our ancestors killed off the people who used to live where we came from. That's a long story in itself. That'd be an interesting genetic study for biblical genetics in the future. But my point is this. Everything we do is tainted. Therefore, we have to come up with a structure so the person who doesn't want to get mud all over them as they walk through this cesspool of a world, who wants to remain clean, who wants to do the right thing, can have an answer to some of the more difficult questions. And one of the most difficult questions is, what are we going to do tomorrow when a doctor says, oh, I can fix that ailment using a technology that we just developed yesterday from a child that was murdered a year ago? That's the challenge that our generation is going to have to meet. I will tell you that as long as this deed was done decades ago, and as long as we didn't materially cooperate in the deed, and as long as we're not benefiting from it, etc., 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 there's all these degrees of separation between us and the act. Most theologians, most ethicists, most people in the world have declared that, you know what? It's not a problem for us, the consumer. It's a problem for the person who did the deed, and we know some of them are. And what's worse for those people is that we're also in the near future going to be able to identify the mother, the father, siblings, aunts and uncles, cousins, and there might be some big issues that pop up because we don't know if the father knew that the mother had an abortion. We don't know if there are cases of incest. We don't know if maybe it was a political or religious figure dilly-dallying with a girl who got pregnant and then had an abortion. We have no idea, but all those things might be revealed in time, and it is terrifying to think about the privacy issues that are about to appear. Before I go, I must thank my supporters. My Patreon list is growing and it's exciting to see it, but Ken F., you are top of the list with all the things you've helped me with. Dave H., Rob S., Adam B., M. Matsky, Daniel P., Jeff VD, Jonathan P. from buymeacoffee.com. Thank you, sir. But also my new subscribers this week, Mark K. and Ted H. Thank you so much. You are helping grease the wheels here, and you're helping keeping biblical genetics going. In fact, you're motivating me to keep on going because I know that people are wanting me to produce more content. So I have to in order to, pay you back for what you've given me. On Buy Me a Coffee, I want to thank just recent donors, Logan K., Stephanie S., and 3 anonymous donors, one of whom I know, and I've thanked her before, but she doesn't want her name appearing on screen, so thank you all very much. This is a very difficult series that I'm going through here. I have labored with this. I have struggled with this. This is the 4th time I've recorded this. I've had all sorts of technical issues, memory problems, I had battery problems, I had overheating problems in my camera. This has been a travail. I've actually filmed in 3 different locations. Finally, I got here, the sun is down, there's no bright spots. I've got a nice color, I think. I'm wearing a yellow shirt, might be too much, I don't know. But I've worked really, really hard on this one. I hope you appreciate it. I'm doing this, Christian, for you. And for you non-Christians, I'm trying to challenge you with a Christian worldview here. Abortion is murder. That puts us in a very awkward position when we're talking about the future of medicine. Stay tuned. There's a lot more coming.